Hello, welcome to this presentation of International Plumbing Code, Chapter 6. My name is Thomas, and in this presentation we are going to focus in on Section 608, which is specifically about the protection of potable water supply, or backflow prevention. Now there is so much to this, and it is such an important topic that that's the only thing we're going to talk about in this presentation, 608. Let's get to it. Now, if you're studying the International Plumbing Code, especially to take a test, I would encourage you at this point to get your book out, follow along with me, make sure that you understand what we're looking at here. There's some tables. You'll see it on the screen, but you'll need to see it on your page so that you know where you're looking for information. Let's start with 608.1. Just in general, what is this all about? Potable water supply systems shall be designed, installed, and maintained in such a manner so as to prevent contamination from non-potable liquids, solids, or gases being introduced into the potable water supply through cross connections or any other piping connections to the system. Backflow preventer application shall conform to Table 608.1. We're going to look at that table, except as specifically stated in sections 608.2 through 608.17.10, and we'll look at those as well. But the point being, the potable water system has to be protected against anything harmful. Have a look at this quick infographic. Backflow can happen. Let's go through this scenario. Let's say you're going to use a dangerous chemical of some kind. You're going to spray for bugs or weeds. And you use a garden hose to fill your sprayer. And you put the garden hose in the tank with the spray chemicals. And that's the first stage of risk, right? Because now we have a connection to something that is dangerous. Now, in a normal situation, that's not a big deal. But what happens if there's a break in the line downstream, somewhere in the main? The city shuts it down, they're digging it up, they turn it off, and we then start to drain the system. If they're able to drain the system and that creates a siphon, it could pull those dangerous chemicals into the main water system, which would then be delivered later when the water turns back on to people's showers, faucets, and whatever else. Drinking water, right? They could drink it right in. This is an example of a back siphonage situation where it's dangerous. Now we might argue, well, what's the probability? I mean, yeah, right, that's actually going to happen. They shut off the water and it really pulls that chemical. How many times has that ever happened? Well, in reality, maybe it's not that big of a risk by percentage, but if it's a risk at all, and if human life is in danger, then we have to take every precaution that we can. We can't ignore this, and that is why we have this section on backflow prevention. Because something as simple as leaving a hose in a utility sink could endanger your very life, there are a number of ways that we can handle backflow prevention to protect against that. But before we get into that, we need to review some of our terms from Chapter 2. These are important words for us to understand when we're discussing backflow, including the words potable water. What is potable water? Well, it's water that's free from impurities present in amounts sufficient to cause disease or harmful physiological effects, and conforming to the bacteriological and chemical quality requirements of public health and safety in your jurisdiction. So that doesn't mean it may be like perfect pure water with absolutely nothing in it. It says impurities present in amounts sufficient to cause disease or harm. So as long as it meets a certain water quality standard, it's potable water. What is non-potable water? Well, it's just the opposite. The definition is simply water that is not safe for drinking, personal, or culinary utilization. Now, as we examine our backflow prevention, we also have to understand the difference between contamination and pollution. That may sound like the same thing, but in code definitions, it is not. Contamination means an impairment of the quality of the potable water that creates an actual hazard to the public health through poisoning or the spread of disease by sewage, industrial fluids, or wastes. So this is where it's actually dangerous and life-threatening. Whereas pollution is referring to an impairment of the quality of the potable water to the degree that does not create a hazard to public health, but that does adversely and unreasonably affect the aesthetic qualities of such potable water for domestic use. That means it's not dangerous, but it's not what you want. Maybe there's something in the water that makes it smell bad, or it changes the color. These are sorts of things that you don't really want to have, but it's not going to kill you. There are ways to prevent against the backflow of these sorts of situations as well. So, we know we need backflow prevention. Now let's look at the table that helps us to know what we can do about it. This is table 608.1, application of backflow preventers. There's 4 columns here. Let's examine each of those columns, make sure we're clear on what they are. The first column is the devices. Those are the things that you can install to protect against backflow. The second column is the degree of hazard. The third column is the application, back pressure or back siphonage, and the fourth column are the applicable standards. So these are the manufacturer standards that would have to be met in order to install this device. Let's have a closer look at column 2, degree of hazard. We're talking about low hazard or high hazard. What's the difference? Well, as we go back to definitions, we see that high hazard equals contamination. We talked about contamination. That means it's going to kill you. Low hazard is referring to pollution. We talked about pollution, and that means it's not going to kill you, but you definitely don't want it in your water. Some devices are not rated to protect against high hazard, but they can stop something for low hazard situations. So we'd want to be aware of which one is which and what our situation is that we're dealing with, and then install the correct device. Let's move on to the third column, is application. There's back pressure and there's back siphonage. Some devices are good for one or the other or both. What's the difference between the two? Well, as we mentioned before, back siphonage is in reference to a negative pressure. It's a vacuum. The water main has been shut down, it's draining the system, and any open faucet or valve is going to create a vent. It's going to flow backwards. It's going to suck the fluids in. Whereas back pressure is referring to 2 systems that are connected, the potable and some other non-potable. Here's an example, low pressure boiler. You have a boiler, it's a mechanical system, it needs some makeup water, a feed from the potable system, but you definitely don't want that boiler water getting back into the potable system. So if you were to shut down the main and there's no protection there, the boiler could actually push pressure back into the main system. This is a back pressure situation. Also not something we want. We have examined the 4 columns. Now let's look down the page. You'll find there are actually 3 divisions of the page. The first section says backflow prevention assemblies. This has about 6 items listed. You know you have a backflow prevention assembly when that device can be tested. So if you look at that double check valve or vacuum breaker and it has test ports, then you know it is an assembly, and these are rated for some of our more critical situations. Now I've tried to come up with some images to illustrate what these things look like. Hopefully these are close enough to give you an idea. Follow me through this list of assemblies and see if you can create a visual connection here. Here's an example of a double check backflow prevention assembly. Again, an assembly because it has test ports. This is a double check detector fire protection assembly. This is one of the most common backflow preventers that we install when we really need something that counts. It's the reduced pressure principal backflow preventer, sometimes known as the RP. The Watts has a model 007, and people love to throw that word around, but Watts is not the only one that makes these. One of the identifying characteristics of this reduced pressure principal backflow preventer is that it has a dump out the bottom. If there is a back pressure situation, it will actually relieve that fluid out the bottom and waste it to the drain. So when you're installing these, you have to put them in a place that you could get rid of that wastewater as it's coming out. You need a floor drain or something. This is a larger version of the same thing, the reduced pressure detector fire protection backflow preventer. And we have the spill resistant vacuum breaker assembly. Let's pause and examine vacuum breakers for just a moment. How does a vacuum breaker stop backflow? Well, a vacuum breaker is used for negative pressure situations. So in normal flow, water comes into the backflow preventer. There's a stop in there that keeps water from getting out of it, and it moves right on down the line. But if there's a negative pressure situation and things are flowing the other direction, then there is a stop that will drop down, air will flow in to break the siphon, and anything that's being siphoned will waste out of the top of the vacuum breaker. This way we can stop anything from flowing into the potable system. All that said, the question is, can a vacuum breaker be used for a back pressure situation? Have a look at your code book. Look back on the table, spill resistant vacuum breaker assembly. It can be used for high or low hazard, but it cannot be used for back pressure. It is only a back siphonage device. Keep that in mind as we go forward, because vacuum breakers are often used in connection with faucets or other devices. They're built right in, but they are not made for back pressure situations. As we continue down this table 608.1, there's another section titled Backflow Preventer Plumbing Devices. Now, a device is something you can install, but notice it's not an assembly. That means you cannot test it. On the list we have anti-siphon type valves for gravity water closet. These are fill valves for a flush tank. Backflow preventer for carbonated beverage machines. Backflow preventers with intermediate atmospheric vents. Dual check type backflow preventers. Hose connection backflow preventers. Hose connection vacuum breakers. Laboratory faucet backflow preventers. Pipe applied atmospheric vacuum breakers. And vacuum breaker wall hydrants frost resistant automatic draining type. Some quick examples here. There's a toilet fill valve, the anti-siphon type fill valve. Backflow preventer for carbonated beverage machines may look something like this. Backflow preventer with atmospheric vents. A dual check type. This is just 2 springs and a piece of a check valve, not for high hazard, but it'll stop some backflow. Hose connection vacuum breaker. A laboratory faucet backflow preventer. It has a vacuum breaker built right into the spout of the faucet. A typical pressure vacuum breaker. Vacuum breaker wall hydrants, frost resistant automatic draining. Let's move on to the last section of table 608.1. These are other means and methods. We're not talking about installing a device, a valve. What we're talking about is the way we're creating the pipes. And air gap is the number one. Air gap is probably, of all forms of backflow prevention, the very best you can do. It's for high hazard, low hazard, back siphonage, back pressure. You just can't beat the air gap. On the list also you have the barometric loop. This is for back siphonage only, and it's kind of a strange concept. Let's hit air gap real quick. Air gaps can be created using fittings or without fittings. Just keep the pipe over the receptacle, and as long as there's a gap, water is not going to be able to get up into the potable system. The barometric loop is some strange configuration of pipes where you have to run it 35 feet up into the air and bring it back down. Other than industrial applications, I don't know where you're going to go put a 35-foot riser and bring it back down. It's not very practical, right? So Utah amendments deleted that altogether. Now that you're familiar with that table 608.1, and that's a really important one, most likely there'll be state test questions coming from that thing. But let's go on to the rest of this section 608. 608.2 talks about plumbing fixtures and states that they should be installed so as to prevent backflow. Think about this. Pretty much all fixtures we install do have backflow built in. A faucet, for example, is above the flood level rim of the sink, and that creates an air gap. There's a built-in backflow prevention. 608.3 talks about devices, appurtenances, appliances. Anytime you hook up a dishwasher, a washing machine, anything like that, there has to be a backflow prevention. An air gap is a good example. You can have an air gap fitting for a dishwasher. In Utah, we don't do that, but they allow us to do an air gap or an air break. 608.4, potable water handling and treatment equipment. Examples, filters, softeners. They have to be located so as to prevent contamination, and they do have to waste through an air gap. Softener drain connections particularly need to be through an air gap. Here's an example of what you don't do with a water softener discharge pipe. Drill a hole in an ABS pipe, stick it in, and tape it up. not okay. This is not backflow prevention. This one's laughable because this comes right out of a water softener installation manual. They say this is the right way to install. Get a brick or a block, zip tie a pipe to it, just keep a gap above it. This is, quote, the right way. In truth, if there's an actual air gap there and it is of the right size, go check out chapter 8 if you're looking at what exactly does an air gap mean. But if that's the case, this could work. What you and I know is that if you put a water softener discharge pipe on a horizontal like that and it's just shooting at the drain, it will flood the room. So there's other ways to handle this, right? You can get an air gap fitting specifically made to handle this situation for water softener discharge. Or you can make one yourself. I thought this was a pretty creative option. 608.5 talks about water service piping and refers us back to what we talked about, making sure that we keep distance from our sewer line if the sewer pipe is not of the right stuff. 608.6, chemicals and other substances shall not be introduced into the system. So we're aware of this, right? If I'm going to be using chemicals, I'm going to be protecting. 608.7 talks about cross-connection control. It says cross-connection shall be prohibited except where approved backflow preventer assemblies, backflow prevention devices, or other means or methods are installed to potable water. This means anytime you have potable water connecting directly to a non-potable water system, whatever that is, maybe mechanical or something else, you have to have something to protect there. 608.7.1 says that cross connections between private water supply and public water supply shall be prohibited. That means I cannot have a well system directly connected to the public system. They want protection there. The 608.8 talks about valves and outlets prohibited below ground, specifically prohibiting the use of stop and waste valves and freeze-proof hydrants. Why? Because both of these have a drain port, a little weep hole, so when you shut it off, it drains down everything that's downstream into the ground. And the problem with that being that whatever contaminated water may be in the ground around the valve could possibly be conveyed or siphoned or whatever into the potable system. So they say these are completely prohibited. Now in Utah, because we use these all the time for sprinklers or for field watering, the Utah amendments has said these are okay. Now where I'm at, we have a secondary water system. There's a potable line coming into our house from the city, and the city also provides a secondary system from their irrigation lines. And that's fantastic for watering our lawn, but horrible if children start drinking from a faucet. For that reason, the code says anytime you have non-potable water system, it has to be identified. A pictograph like this is going to really indicate, hey, this is not safe for drinking. Further, it says the words caution non-potable water, do not drink, have to be clearly visible, legibly written with half-inch letters or larger. There should be some really obvious signage by any sort of an outlet so that people don't drink from this. Yeah, you really don't want your kids running through the sprinklers if it's reclaimed sewer water, you know what I mean? Non-potable water should be conveyed through a specific pipe. 608.9.2 talks about the labeling and marking on this pipe. First of all, the magical color is purple. Don't forget that. Anytime you see purple pipe, that means this is non-potable system. It should also have those words right on it. Caution, non-potable, do not drink. And that should be marked at least every 25 feet on the pipe. 608.10 prohibits the reutilization of water from a non-potable system. It says, water used for heating or cooling shall not be returned to the potable water system. Now you might think, well, all it did was circulate through and never touched anything outside of that. Well, yeah, but it's picking up a lot of junk from inside of that system as it cycles over and over and over and over. Such water shall be discharged into a drainage system through an air gap. We never allow it back into the potable. 608.11 says, piping that has been utilized for any purpose other than conveying potable water shall not be utilized for conveying potable water. Obviously, this means don't ever reuse pipe for potable systems. Maybe it's useful in some mechanical setting outside of potable, but never bringing used pipe into a potable system. 608.12 addresses potable water tanks. They have to meet that NSF 61 standard, and it says they're not supposed to be painted by anything that would affect the odor, color, taste, or whatever. 608.13 says potable water shall be protected against contamination from pumps and other appliances. Now I want you to have a look at 608.14. Look down in your book. There's a list of the backflow preventers we've been talking about, not all of them, but a lot of them, with details about how they're to be installed and the standards that they're supposed to meet. I'm not going to go into that much detail, but you should know that if you need specific information about backflow preventers, dig in there, you'll find it. But it is worth looking specifically at 608.14.5, pressure vacuum breaker assembly. It says these assemblies shall be installed with the critical level of the assembly located not less than 12 inches above all downstream piping and outlets. Pressure vacuum breaker assemblies shall not be installed in locations where spillage could cause damage to structure. When a backflow situation happens, vacuum breakers just dump. They make quite a mess. They're great for use outside. They can be used in mechanical rooms with floor drains, but you don't want them just, somewhere it's going to be damaging cabinets or flooring or anything else. Going back to the 12 inches, these are often installed in sprinkler situations. This graphic comes from irrigationrepair.com. They're pointing out specifically you have to have 12-inch minimum above the highest outlet or water level. So in a sprinkler system, if you're going to use a vacuum breaker, you look around at all the sprinkler heads and you make sure that that vacuum breaker is 12 inches above any of those sprinkler heads. Now what if you're on a hill? If you're on a hill and your source is 10 feet below the highest head, clear up the hill somewhere, and you want to use one of these, you're going to have to get a good 11-foot pipe and get it above. Well, that's obviously why we don't use these a lot in a hill situation. There's other options, and we'll get to that in a minute. The 608.15 talks about the location of backflow preventers. If they're going to be installed, at a minimum, access must be provided. You're going to have to get to it to service and to replace it eventually. So access is required. Also, it has to be installed in a location that is not subject to freezing. Backflow preventers are installed all the time outside for irrigation lines, as they should be, but if they're left out there in conditions where they can freeze, they will split, break, pop, burst, flood, and they will have to be replaced, which is quite expensive. Now, if you're going to install it in a location where it could freeze, so they can be installed there where they can be removed by means of unions or protected from freezing by heat insulation or both. Ideally, you have unions, you shut it down, drain it, remove it during the winter so that it doesn't freeze. Here's an example of a backflow preventer. It's an RP. It has unions. You can take it off. The only thing that can make this better is if it were done in steel or something that's not going to break as soon as the lawnmower hits it. 608.16 talks about protection of potable water outlets. Now that's faucets, any of the fixtures that we use. It mentions air gaps. 608.16.4 specifically for the use of vacuum breakers, it says the critical level of vacuum breaker shall not be less than 6 inches above the flood level rim. Let me point out, we were just looking at vacuum breaker assemblies and how they should be 12 inches above. We're talking about an assembly that has the test ports. That's for higher hazard situation. Those are irrigation installations. This is different. It is a vacuum breaker, but now we're looking at fixtures, right? Anywhere that it may be used to protect potable. 6 inches above flood level rim of the sink is good enough for a vacuum breaker. Once again, I would refer you to your book. Have a look at 608.17. This is what gives us a list of places where we'd have to provide backflow protection. I'm not going to go through every scenario, but let me just list them out here as they come from the book. Beverage dispensers, boilers, heat exchangers, fire sprinklers, lawn irrigation, chemical dispensers, portable cleaning equipment, dental pumping equipment, and humidifiers. This is a list of some of the places that you would definitely need to install backflow prevention. There are likely others. Let's zoom in on just one of those in 608.17.5. It talks specifically about connection to lawn irrigation. We'd mentioned that you can use the vacuum breaker assembly, but also you can use a reduced pressure principle backflow preventer. These are the two options you can use for an irrigation system coming from the potable water. Ever seen this image? Yep, this came from American Standard. Plumber protects the health of the nation. This section, 608, is one of the most important of all of the sections in the plumbing code when it comes to doing just that, to protecting health and preserving life from poison, from contamination that could cause tragedy, real tragedy. So as plumbers, being aware of backflow prevention, being aware of the preventers that we can use to create that protection is essential as we fulfill our role in protecting health and sanitation for the public, for our nation. I'll see you next time.